Unit 3, Test 2, Review, Parallel perpendicular lines, we have direct variation, and we have arithmetic sequences, or the nth term of a pattern. Let's start with number 1, perpendicular to y equals negative 3x plus 4. We're trying to find the equation of a line that is perpendicular, equation meaning slope-intercept form, of a line that is perpendicular to this line, but our line has to go through 9, 2. So the way we're going to be able to get our equation in slope-intercept form is to start by using the point-slope formula, which is y minus y1 equals m x minus x1. Our ordered pair, 9, 2, is going to go into the x and the y. So y minus 2 equals m x minus 9. The only problem is I don't know the slope of my line yet. I know it has to be perpendicular to negative 3x plus 4. Well, the slope of this line is negative 3. If my line is perpendicular to that, then it has to have opposite reciprocal slopes. Opposite reciprocal slopes. So we take slope of negative 3, pretend like it's negative 3 over 1, we flip it upside down to 1/3 and change negative to positive. So this is our slope here. So that's going to go in that spot there. 1/3, parentheses, x minus 9. Now I have to take that equation and solve for y. So I'm going to distribute 1/3 x minus 1/3 of 9 is 3. So y minus 2 equals, I'm going to rewrite it up here, y minus 2 equals 1/3 x minus 3. Add 2 to both sides, and we have y equals 1/3 x minus 1. That line is perpendicular to negative 3x plus 4, and it will pass through 9, 2. There's number 1. Number 2, parallel to 2x plus 4y equals 12, and goes through 8, negative 2. I need some room. Erase part of this. I guess you can just rewind if you didn't get that far. I need to know the slope of that line. 2x plus 4y equals 12. If I take that and solve for y, then I know the slope. So I'm going to get y isolated. Minus 2x to both sides. 4y equals negative 2x plus 12. Divide by 4. Y equals negative 1/2 x plus 3. There's my slope, negative 1/2. That's the slope of 2x plus 4y equals 12. My line is parallel to that. I know that parallel means same slope. So my line is going to have a slope of, oh, that's ugly, negative 1/2, and it's going to go through 8, negative 2. So that's where we use point slope formula. Y minus negative 2, which is plus 2, equals negative 1/2 x minus 8. Then I just isolate the y, and I have my equation. Negative 1/2 x, negative half times negative 8 is positive 4. Minus 2 to both sides. I have y equals negative 1/2 x plus 2. ugly plus sign. Come on. There we go. Number 3, create an equation that is parallel and an equation perpendicular to this line. I need to know what this line is before I can do anything. I need the equation. I know the slope is rise down 3, run over 4, so negative 3/4 x plus my y-intercept is 3. So there's the equation here. I need to create an equation parallel and an equation perpendicular. So parallel is going to be anything with the same slope, negative 3/4. So y equals negative 3/4 x plus, here's where we can be creative. We can have any number in the world that we want as the y-intercept except positive 3. If I made it plus 3, it'd be the exact same line as the purple line over here, which I don't want that. So anything other than plus 3. I want to say plus 5. That is parallel. Perpendicular. Is y equals, I need the slope to be opposite reciprocal of negative 3/4. So positive 4/3. And I can't have the exact, well, it's not possible for it to be the exact same as this purple line anymore because the slope is different. So now the y-intercept can be anything, including plus 3 or any number in the world. Let's go 17. There we go. And just keep in mind that this number can be many different numbers and still be correct. Slope is what has to be negative 3/4 and positive 4/3. Okay, moving on to number 4. We need to find the formula that can be used to find the nth term of these patterns, and also what would the 30th term of these patterns be. So first we'll find the formula. The formula is going to be in the form a sub n equals mn plus b. M is my slope. That's what we're counting by. So if I look at this pattern, negative 5 to negative 3 to negative 1 to 1 to 3, those are all plus 2. So 2n plus b. b is my y-intercept. I need to take this pattern and go back to the 0th term, which is going to be negative 7 if I go that direction. So if I'm adding 2 to the right, then I need to minus 2 to the left, which would give me negative 7. 4 is throwing me off. So there's my equation. A sub n equals 2n minus 7. Same as plus negative 7. The 30th term now is going to be the answer when I plug in a 30. So a sub 30 is 2 times 30 minus 7. That is 60 minus 7, 53. Next one, this little pattern where it looks like we're starting at 60 and counting by tens. So a sub n equals our slope, our rate is plus 10. So 10n plus our 0th term, back up, minus 10 would be 50. So it's like we're starting at 50 and then counting up by tens every time. 60, 70, 80, 90. So the 30th term now, a sub 30 is going to be 10 times 30 plus 50. Well, that is 350. Switch to red. Number 6, 95, 92, 89, 86. It looks like it's going down 3, down 3, down 3. So a sub m equals our slope, our rate is -3n plus, now our starting number, our 0th term, back up and add 3, 98. So a sub 30, -3 times 30 plus 98. So we have -90 plus 98 gives us 8. 8 would be the 30th term there. Number 7, moving on. This video is going to be forever. I'm only 10 minutes in. I'm already 10 minutes in. F of x goes through -1, 6 and 1, 12. So before I do any work, I want to visualize that. Over here, I see -1, 6 is somewhere up here. 112 is somewhere way up there. So f of x kind of looks like that. G of x goes through 3, -4. So 3, -4, stay there. And is parallel to f of x. So, close enough. That's what g of x sort of looks like. I need to find the equation of that red line. First, I'm going to use point slope formula. So, y minus y1 equals m x minus x1. I need a point, which I have, and I need a slope, which I can get. So I'm going to use the point that f of x goes through and find its slope. Because if I know the slope of the blue line, I know parallel means same slope. So slope formula, y minus y over x minus x is going to be 6 over 2, which is 3. So my line has to have the same slope. Y minus, here I'm going to use, now that I know the slope, I'm done with f of x. I don't need f of x for anything else. Those points are just distracting me. Make them go away. Y minus -4 equals m, which is 3, x minus my x value, which is 3. So change that to y plus 4. We have 3x minus 9. I need to subtract 4 to make that go away. And y equals 3x minus 13. The reason I wanted to sketch out this graph over here is because I wanted to check and see that that equation sounds reasonable. A positive 3 slope, that looks to be up 3 over 1, that could be right. Minus 13 as a y-intercept, well, it's way down low on the y-axis, so that looks like it is reasonable. I'm going to assume that everything is correct. So I'll leave that answer there. Second question down here, number 8. F of x passes through, I want to sketch it out again. I don't have a lot of room though. We'll sketch it here. 6, -2, there, and 11, 8. So up there. There's f of x. G of x is perpendicular and goes through -14, -7. So way down here. Perpendicular is going to look something like that and make a 90-degree angle. So what I already know is this green line, g of x, has to have a negative slope and it has to have a y-intercept that's also negative. So I already need to be expecting negative m and a negative b. I'm going to use point slope formula. First, I need the slope of f of x, the blue line. I'll underline it in blue. Blue line. There we go. Once I know its slope, which is 8 minus 2 over 11 minus 6. Oh, whoa. 8 minus -2 over 11 minus 6. That's 10 over 5 which is 2. My line is perpendicular. Perpendicular means opposite reciprocal slopes. So change 2 over 1 to 1 over 2 and make a negative. That's my M. I know my line has to have an M, a slope of negative 1/2, and go through negative 14, comma, negative 7. So, let's go skinnier. Mark's too fat. Point slope formula now. Y minus negative 7 equals M x minus negative 14. Change those to plus, change those to plus. Distribute here, negative 1/2 x minus 7 minus this 7 to make that cancel out. And we're left with y equals negative 1/2 x minus 14. I knew I needed a negative slope. I knew I needed a negative y-intercept, and got them both. I'm going to assume, since that's reasonable, I think it's good. Negative 1/2 x minus 14. And you could graph that on your calculator and trace menu 5-1, scroll around and double check that it does go through negative 14, comma, negative 7. Number 9, create an equation steeper than the line above. Oh, I can barely see it up above. I'm encroaching on its equation. So we have y equals 3x minus 2. If I need an equation steeper than that, I know steeper talks about the slope. I need a higher or a bigger, let me say, bigger slope. So I'm going to say y equals 4x minus 2. The only requirement is that you have a bigger slope than 3. Number 10, create an equation flatter than the line above. Well, flatter, that's the opposite of steep. I need a smaller slope. And this is all ignoring any negative signs. Just the number there, not the sign of it. 3 tells me how steep it is. Negative 3 is technically the exact same steepness. It's just in the opposite direction. So we're not looking at the signs here, just the actual number. I need my slope to be smaller than 3. So I'm going to say y equals 2x minus 2. 11, create an equation shifted higher than the line above. Shifted higher means a bigger, well, what tells me where my line is shifted? That would be the y-intercept, the b value. So as long as I have a higher or bigger y-intercept than the original line, which was negative 2, then it's going to be shifted higher. Slope doesn't matter. So y equals 3x. Anything higher than negative 2, I'm going to say plus 5. Again, there are a whole bunch of right answers there. Anything above negative 2 is good. And number 12, shifted lower. That means a smaller y-intercept. So y equals 3x, negative 2, something smaller than negative 2, negative 3. It's going to be 1 unit lower than 3x minus 2. Oh, okay. Next page, number 13, direct variation now. If y varies directly with x, and y equals 12 when x equals 8, what is y when x is 20? 2 ways you can do it. I can set up a proportion, y over x, which is going to be 12 over 8, has to equal the other y over x, which is blank over 20. Cross multiplying here can 12 times 20, what is that? 240 divided by 8 is 30? 30? Yes, 30. So, there's one way to do it. That's not my favorite way. It's probably the easiest way, but the way that shows or that brings in everything about direct variation is going to be to get the equation. The equation meaning y equals kx. I know k can be found by doing y over x. So if I take y, which is 12, over x, well, not x, 8, that's going to give me k. 12 over 8 is 3 over 2. So my equation is y equals 3 over 2x. Well, they tell me x is 20. So I can say y equals 3 over 2 times 20. Once I do the math, that's 60 over 2, 30. This way is a little more work, but it also gives you a more full answer. It gives you the equation, which is y equals 3 over 2x. It gives you the k value, which is 3 over 2. So, depending on the question, there are other easier ways of doing it. They just want y. So, as long as you can get 30, you're good. The next few questions require a little more thought put in, though. The driving distance on a road trip varies directly with the time I spend driving. So this is like y varies directly with x. Distance varies directly with time. I can drive 150 miles in 2 hours. Well, I know k is y over x. So y is distance, distance is miles, 150 over x is time, time is 2 hours, 150 over 2 is 75 miles per hour. So there's my k. My equation, y equals kx, is y equals 75x. If I were to drive for 5 hours, how many miles could I drive? Well, hours, I know, is x. So this is my x value there. I'm just going to plug in 5 hours. So y equals 75 times 5. And what is 75 times 5? 75 times 2 is 150. Another 2 is 300. 375. So 375. Number 15. The amount of calories in a piece of cake varies directly with the size of the cake. So y varies directly with the size. Calories is y, size is x. Need a new color. Last problem was red. There we go. So, got to figure out what x is and what y is first. 6-ounce slice of cake has 350 calories in it. K is y over x. Y is calories. Calories is 350. Divided by x is size. Size is 6 ounces. 350 divided by 6. I'm going to cheat and calculate that really quick. 350 divided by 6 is 58.3. This is the time when you will want to use decimals. I don't care if my cake has 175 thirds calories per ounce. I want to know that my cake has 58.3 calories per ounce. That is more meaningful in this situation. That's why we do the decimal, not the fraction. The equation, y equals 58.3 x. Y equals kx. A 10-ounce slice of cake is going to be how many calories? Well, take that equation and just plug in 10, which is my ounces. That's my size here. That goes in for x. So 58 y equals 58.3 times 10. And that's going to give me 583. That's a lot of calories for cake. 16. The price of gasoline, that's my Y, well, price is Y, is directly proportional. That's the same thing as varies directly to the amount of gallons you pump. There's my X. Y varies directly with X. 5 gallons cost $10.48. So find K. K is Y over X. Y is the price, $10.48. Divided by, go away. Whoa, 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 whoa. I don't like that that's there. Okay. Divided by X. X is gallons. Gallons is 5. So 10.48 divided by 5 is 2.096. I'm going to round that up to 2.1. Equation. Y equals 2.10x. Actually, 2.10 would be money. Anytime we're looking at money, that's dollars per gallon for gas there. I don't need the third decimal value when I'm looking at money. I can round that off. So 2.10x. If I were to pump 8 gallons, I'm just going to plug 8 in for my x. So y equals 2.10 times 8. And we get $16.80 for 5 gallons. Lastly, we're moving on to direct variation. Just straight, is it direct variation or not? If they are, find the K, constant of variation. So we have equations, tables, graphs. I know that an equation needs to be able to be written as y equals kx if it is a direct variation. So I'm looking at, red and blue. Can this be y equals kx? Right now it's not, but what if I isolate the y? If I minus 4x to both sides, y equals negative 4x plus 4. Big fat no on that one. Not a direct variation. Because of the plus 4 there, the y-intercept. Can't have anything extra. Number 18, I know a table has to have the same y over x for every row on the table if it's a direct variation. So, 15 over 5 is 3. 24 over 8 is 3. 42 over 14 is, I think, 3. Yes, it's 3. Everything is the same. Everything is 3. So, yes, this is a direct variation. What is my K? It is y over x, which is 3. A graph has to be straight line through the origin. Big no there. Doesn't go through the origin. Another equation has to be y equals kx. So, isolate the y. Minus 5x. Negative 4y equals negative 5x. Divide by negative 4. And I have y equals, that simplifies to positive 5/4 x. So, yes, that is a direct variation because this is y equals kx. And k is just 5 over 4. 21, another table. Are the y over x's the same? Let's check. We have 6 over 2 is 3. 8 over 3 is not 3. So I don't even really need to figure out what it is or go any further. I know they're not all the same. Just to double check, 10 over 4 is also not 3. None of those are the same. So, no, not a direct variation there. 22. Y equals negative 12. Y minus negative 12 equals 4x minus 12. Can this be put in y equals kx? Well, if I add 12 to both sides, negative 12, positive 12 cancels out. Y equals 4x, another negative 12, positive 12 cancels out. And there we go. That is y equals kx. This is a yes. K equals 4. 23, y equals 2 over x. Well, y has to equal k times x for a direct variation. It cannot be k divided by x. That's not the same, so not a direct variation. Number 24, straight line through the origin. That's supposed to be through the origin. I got it as close as I could. I know it goes there. Believe me, it goes there. That is a mouse. That's going to be a yes. It's a straight line through the origin. Now, what is k here? Too much purple side by side. I need to know the slope, the rise and run. I don't have any grid lines on this graph, but you can tell that it goes at a 45-degree angle. If I go up and over, I'm rising the same. I don't know, let's say that looks like 4. Well, that's also 4 there. Rise over run is going to reduce to be positive 1. If you thought, that doesn't look like 4, that looks more like 2. Well, the run is also going to be 2 then because it's the same amount. So 2 over 2, still 1. How we're counting doesn't matter as long as it's the same rise and the same run here. I know it's easier with little tick marks to count, but it's all good. There we go. Direct variation. Got a test on Wednesday. Good luck. Be prepared. Come tutoring if you're still struggling with a few topics. And I'll see you then.